Good morning, students. Welcome back to the class. So in the last class we started with inverse trigonometric functions. So in the beginning I explained how the chapter will actually exist and how the chapter will not going to exist. So basically a trigonometric function, if you consider any trigonometric function, is not going to be bijective, but inverse will exist. Inverse exists only if the given function is going to be bijective. To make it inverse exist for trigonometric functions, we should restrict the domain and range. So for example, if I state f from r to r given by f of x equal to sin x, this is not a 1-1 function, because we know that sin pi by 6 is 1 by 2, even sin phi by 6 is also 1 by 2. Elements are different, images will be same. In such case, the function is not going to be 1-1, hence it is not going to be bijective. So if it's not bijective, the inverse will not exist. So to make it exist, what we will do is, we will restrict the domain here. The domain will be restricted between closed interval minus pi by 2 to pi by 2, and the range will be restricted between the real numbers minus 1 and plus 1. So now for this function, okay, it's no more defined from r to r, it is defined from, the domain will be minus pi by 2 to pi by 2 and the range will be taken from minus 1 to 1. In such case, we will say that this function is going to be a bijective. So once it's bijective, its inverse will exist, and inverse of sine is denoted by sine inverse x, like this. So this is how the beginning of the chapter was done yesterday. So we have defined the domain and range for all the 6 ratios. We have given a table. That is the most important table throughout the chapter. So apart from that, we have studied properties. So property number 1, which was sine inverse of sine x can be written as x. I told you how to remember this. X is inside a normal trigonometric function, then x should be in terms of radians. So minus pi by 2 to pi by 2. So just below this we can write sine of sine inverse x equal to x. Now x is inside inverse trigonometric function. Now in such case, x should be a real number, minus 1 to 1. So that's property number 1, first one. And the second one is given by cos inverse of cos x equal to x when x belongs to closed interval 0, pi. And just below this, cos of cos inverse x can also be written as x if x belongs to closed interval minus 1, 1. If x is present inside inverse trigonometric ratios, the values of x are going to be real numbers. If x is present inside a normal trigonometric ratio, the values of x are going to be real now. Sorry, it's going to be in terms of degrees or radians. Now under this third one, tan inverse of tan x can be written as x, and the next one is tan of tan inverse x can also be written as x. But the condition, x is present inside a normal trigonometric ratio, so x should be open interval minus pi by 2 to pi by 2, and the next one is inside the inverse ratio, so x should be any real number. So this is property number 1. So the next one after this, we studied the property based on negative sign for inverse trigonometric ratio. So property number 2 was, under this first one, sine inverse of minus x equal to minus sine inverse x. Second one, cos inverse of minus x equal to pi minus cos inverse x. And the next, tan inverse of minus x equal to minus tan inverse x. Now let's go to the fourth one. The fourth one will be, let's go for secant inverse. Secant inverse will be pi minus secant inverse x. And fifth one, cosecant inverse of minus x is minus cosecant inverse x. And sixth one, the last one should be cot inverse of minus x equal to pi minus cot inverse x. So the second property is defined for negative sign inside the inverse trigonometric ratios. So how to remember it? See, remember there are 3 ratios which starts with pi. So for cos, secant and cos, okay, the right hand side starts with pi. For the remaining 3, just going to start with a negative sign. I've told you how to prove this, so please make a note of this. Let's go for the next. Property number 3. First one, sin inverse x can also be written as cosecant inverse of 1 by x. See, in trigonometry we write sin theta equal to 1 by cosecant theta, but in inverse trigonometric ratio, sin inverse x will be cosecant inverse of 1 by x. Now, under the second one, this property can also be written as cosecant inverse x equal to sin inverse 1 by x. Either way it's fine. Now, the next one under this, cos inverse x can be written as secant inverse 1 by x. Otherwise, secant inverse x can be written as cos inverse 1 by x. Now, similar to this, in terms of tan inverse x equal to cot inverse 1 by x, or cot inverse x can also be written as tan inverse 1 by x. Just similar to what we use reciprocal properties in trigonometric ratios. So that's about property number 3. The next, property number 4, we have 3 sin inverse x plus cos inverse x equal to pi by 2. Second one, secant inverse x plus cosecant inverse x equal to pi by 2. And one more, tan inverse x plus cot inverse x equal to pi by 2. It's just similar to 3 identities what we have it in trigonometric ratios. So similar to that we have in terms of inverse also. So these are the 3 identities. Now after this we will go for the next one, property number 5. We went for tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. So the next one was, I told you the derivation is not there in EPL. To make a note, I have explained you already. Tan inverse x minus tan inverse y equal to tan inverse of x minus y by 1 plus xy. So till here we have done the problem, we have done all the derivations. Now apart from this, what we have studied yesterday was finding something called as principal values of the given inverse trigonometric ratio. What is principal values? It is nothing but the range of inverse trigonometric functions. That is the meaning. Okay, for example, we have cos inverse of 1 by 2. What is the range of cos inverse was? The range of cos inverse was minus 1 to 1. That's fine, right? Okay, sorry, not minus 1 to 1, it's going to be 0 comma pi. This was the range. Okay, domain was minus 1 to 1. That's fine. So any value of cos inverse which lies between 0 comma pi we need to obtain, and this simply is nothing but pi by 3. Okay, I told you how to solve the problem. The problems are based on the negative sign inside the inverse ratio. I have explained enough number of problems there. Okay, we have done the first main and the second main problems based on finding the principal value of the trigonometric ratios. So let's continue with the third main. In the third main, the first problem is, again the heading is same, evaluate each of the following. Now under that, first one is tan inverse 1 plus cos inverse minus half plus sin inverse minus half. I told you yesterday in the beginning class. Okay, see, the first importance in inverse trigonometric function or any trigonometric function should be given for the negative sign inside. Got it? So as you notice, there is a negative sign in cos inverse, there is a negative sign in sin inverse. So first let's apply the property. So this can be written as tan inverse 1, let's retain cos inverse of minus x pi minus cos inverse x. Students, if you are ready with the formulas, these things are not at all going to be difficult. Okay, now we have a formula. Sin inverse of minus x is minus sin inverse x, so plus into minus will be minus, so this is going to be minus sin inverse 1 by 2. So let us start simplifying this now. Tan inverse 1, in tan table we will get 1 for pi by 4, so tan inverse 1 is pi by 4 plus pi as it is. Cos inverse half, so in the cos table remember we will get half for pi by 3, that is 60 degrees, so this will be pi by 3 minus sin inverse 1 by 2. In sin table we will get 1 by 2 for 30 degrees. Let's write everything in terms of radians, it will be better, right? So let's go for simplification of this thing. So this is going to be pi by 4. So if I take LCM, this will be 2 pi by 3 minus pi by 6. So the rest is take the LCM for 4, 3, 6 and simplify, you will get the answer. So that's the first one. Let's go for the second. Second problem under this is given by tan inverse root 3 minus secant inverse of minus 2 plus cosecant inverse 2 by root 3. So how to solve this one? So once again the first importance should be given for the negative sign. So you can notice there is a secant inverse of minus 2. So I'll apply the formula here. So let's write tan inverse of root 3 minus, open the bracket, secant inverse of minus x is pi minus secant inverse x plus, let's retain this, cosecant inverse 2 by root 3. Now let's simplify this. Tan inverse root 3, tan inverse root 3 is going to be pi by 3. Tan 60 will be root 3 minus of pi minus. In secant table, remember secant inverse of 2 is nothing but pi by 3. Secant 60 will be 2 plus cosecant inverse 2 by root 3. If you remember sine table, that's enough. We will get root 3 by 2 as 60 degrees in sine. So here this is going to be pi by 3. So let us simplify it further now. Pi by 3 minus 2 pi by 3 plus pi by 3. So let's take LCM for this. So on taking LCM, this is going to be 3. So pi minus 2 pi plus pi. Everything get cancels. So the value is going to be 0. Let's move on to the next one in this. Under this problem number 3. Problem number 3 is given as cos inverse 1 by 2 minus 2 into sin inverse minus 1 by 2. So once again the simplification start from the negative sign. So let's retain the first sign, cos inverse 1 by 2 minus 2 as it is. Now apply the formula. Sin inverse of minus x is minus sin inverse 1 by 2. So let's go for the simplification. Cos inverse 1 by 2. So in cos table we will get 1 by 2 for 60 degrees. In radians it's going to be pi by 3. Minus into minus will be plus. Write down 2 as it is. Sin inverse 1 by 2. In sine table we will get the value of 1 by 2 for 30 degrees. So pi by 6. Simplify this. So it's going to be pi by 3 plus pi by 3, or the value is simply going to be 2 pi by 3. Students, the only one thing is if you have studied the formulas, you have practiced the formulas, there is nothing called as difficulty in any stages of these problems. Okay, so please be ready with the formulas and you can manage the things quite easily. Now let's go to the fourth main. Now in fourth main, again it's a problem based on finding the principal value. The first problem under this, sin inverse 1 by 2 minus 2 into sin inverse 1 by root 2. So there is no negative sign inside the inverse ratios. So simplification will start at sin inverse 1 by 2 pi by 6 minus 2 into sin inverse pi by 4. Sorry, sin inverse 1 by root 2 will be pi by 4. You can eliminate this. So pi by 6 minus pi by 2. So on taking LCM, pi minus 3 pi or minus 2 pi by 6, or it's simply going to be minus pi by 3. That's fine. So that's the first problem. So we have one more in this. The second problem is, under the second problem, sin inverse minus half plus 2 into cos inverse minus root 3 by 2. So there are negative signs actually here also there is a negative sign. So we're going to start simplification from this step. So let's consider sin inverse of minus x is minus sin inverse x plus 2 multiplied by. Now the reason for the bracket is we have cos inverse minus x. Cos inverse of minus x is pi minus cos inverse x. Now it just we need to replace the values. Sin inverse half is going to be pi by 6 plus 2, open the bracket, pi minus cos inverse root 3 by 2. We know that cos inverse of root 3 by 2 is going to be pi by 6. Just reading the table in the reverse order. Okay, so this is minus pi by 6 plus, let's multiply 2 pi minus 2 pi by 6. You can eliminate this. So let's go for further simplification. Minus pi by 6. So on taking LCM, this will be 6 pi minus pi by 3. Let us take LCM further. So the further LCM will be 6 minus pi plus. Now this is going to be 5 pi in multiplied by 2. That's going to be 10 pi. Or it's going to be 9 pi by 6 or 3 pi by 2. That will be the simplest form. So you can just notice, students, if you know two things. One is negative sign for inverse ratios and the table from the first year trigonometry. Okay, if you know these two things, then this first main finding the principal values are going to be quite easy. So just be ready with these two, and you can solve any problems from this. Okay, only two gradients are main gradients are needed. So one is first year trigonometric table. The second one is negative signs for inverse trigonometric ratios. If you know these things, whatever the problems we have done it from yesterday, every problem you can manage. Clear? Now let's start the main thing. NCERT exercise 2.1. You'll be asking, sir, why so far we have done so many problems? What is the use? Quite simple. You practice, now you have practiced enough number of problems. Now you will feel once we start NCERT problems are nothing. You are in such a stage. Okay, so it's quite easy to solve the problems based from problems from NCERT. You can just notice actually. So worked example 1, find the principal value of sine inverse of 1 by root 2. So what is sine inverse of 1 by root 2? How to get it? Quite simple for us. In sine table, sine pi by 4 is 1 by root 2. Therefore, sine inverse 1 by root 2 will be equal to pi by 4. I told you how to read it actually in the table. So sine inverse of 1 by root 2 is simply going to be pi by 4. And what is the meaning of principal value? Because this value lies in the range minus pi by 2 to pi by 2. No need to write it. I'm just simply telling you what is the meaning of principal value. Okay. Now under the second one, find the principal value of cot inverse minus 1 by root 3. So I told you importance should be given for minus sign. Okay. So cot inverse of minus x, we have a formula. So what is cot inverse of minus x? Pi minus cot inverse x. So apply the formula here. Pi minus cot inverse 1 by root 3. So pi as it is minus. In cot table, cot pi by 3 is 1 by root 3. Okay, so cot inverse 1 by root 3 will be pi by 3. Simplify. The answer is simply going to be 2 pi by 3. Now you notice how neatly we are able to understand just because we have practiced enough number of problems here. So this is not going to be difficult for us. Clear? Right. Now let's move on to exercise. So in exercise there are 10 problems. So every problem is based on finding the principal value. So I'll explain one by one. Now let us start exercise first problem. Under that, the first problem is finding the principal value. The first problem is given by sine inverse of minus half. Sine inverse of minus half can be written as minus sine inverse half by using the property of sine inverse of minus x equal to minus sine inverse x. Now what is sine inverse half? In sine table we will get 1 by 2 for 30 degrees. I suggest you to practice in radius because most of the problems in future or most of the objective problems they will give it in terms of radians only. That means whole trigonometry most of the times will be studied using radians rather than degrees. Still, if you are uncomfortable, you can go with degrees. Okay, I won't say no for it, but I suggest you to practice in terms of radians. That's easy and that is the way we need to practice. Okay, let's have the second problem. The second problem is cos inverse of root 3 by 2. So in cos table, for which angle we will going to get root 3 by 2? For 30 degrees. That is pi by 6. Correct? Okay. There was no negative sign, so things will go simple. Okay. Now the next one was cosecant inverse 2. Sir, I don't remember for cosecant. No problem. Convert cosecant in terms of sine. This can be written as sine inverse 1 by 2. Because cosecant inverse x is sine inverse 1 by x. Correct, right? And in sine table, for which angle you will going to get 1 by 2? Pi by 6 only. Correct, right? Right. Now the next, let's go for the fourth one. Problem number 4 is tan inverse of minus root 3. So there is a minus sign here. So this should be applied as tan inverse of minus x is minus tan inverse x. Properties applied, right? Tan inverse of root 3 in tan table. Okay, in the table what we know, okay, in that one root 3 we will get it for 60 degrees. So answer will be minus pi by 3. Fine students, now let's move on to the fifth one. Sorry, there is some problem. Problem number 5. So problem number 5 is given by cos inverse of minus half. What is cos inverse of minus half? Simplification starts from the negative sign. So cos inverse of minus half is pi minus cos inverse half. Use the property cos inverse of minus x equal to pi minus cos inverse x. I will just repeat once again. Throughout this chapter, your first importance should be given for negative sign. Simplification starts from there. Okay, and now let's go for it. Pi minus cos inverse 1 by 2, simply pi by 3. Cos 60 is going to be 1 by 2. Correct? Okay. So on taking LCM, the value will be 2 pi by 3. Let's move on to the next. Problem number 6. So it is given as tan inverse of minus 1. Tan inverse of minus 1, apply the property first. Tan inverse of minus x is minus tan inverse x, and in tan table we will going to get 1 for 45 degrees or pi by 4. So answer will be minus pi by 4. Let's go for 7th one. 7th problem is given as secant inverse 2 by root 3. So if you remember secant table, you can do it directly. Otherwise secant inverse can be converted in terms of cos inverse. So this can also be written as cos inverse root 3 by 2. Right. What is cos inverse of root 3 by 2? 30 degrees. That's pi by 6. So that's the 7th one. Let's move on to the 8th problem. Now the 8th problem is cot inverse root 3. Cot inverse root 3, it's a direct value from the table. We will going to get root 3 in cot table for pi by 6, that is 30 degrees. Next, 9th one, cos inverse minus 1 by root 2. So once you choose a negative sign, apply the property. Cos inverse of minus x is pi minus cos inverse 1 by root 2. Pi minus cos inverse of 1 by root 2 is pi by 4. On taking LCM, you can just simply write it as 3 pi by 4. Right. Now the last problem under this is cosecant inverse of minus root 2. What is cosecant? Now here don't directly apply cosecant inverse in terms of sine inverse. First apply the negative property, and then if you want you can convert it in terms of sine inverse. So cosecant inverse of minus x is minus cosecant inverse root 2. Now you can apply the property if you want. If you don't remember cosecant values, directly apply this property. If not, apply cosecant property directly. So cosecant inverse root 2 can be written as sine inverse 1 by root 2, and sine inverse 1 by root 2 will be pi by 4. So answer is simply going to be minus pi by 4. So you can just notice it's not at all difficult because plenty of columns. We have done it in the exercise, okay, in the illustrative examples. We have learned the concept, and now this is nothing for us. That's what you should feel. Yeah. So second mean, find the values of the following. See, first mean was purely based on single inverse trigonometric ratios. Now they will give you some difference of inverse more than one. Actually we have to simplify. Okay. And now under that first problem is we have to find the value of tan inverse of 1 plus cos inverse of minus half plus sine inverse of minus half. Okay, let's move on. I know tan inverse of 1 directly, I can write it, but first I should look for the negative sign in any inverse trigonometric functions. That's my first job. Okay, so tan inverse 1, let's retain cos inverse of minus x pi minus cos inverse x, sine inverse of minus x minus sin inverse x. Property, negative property is applied. Now let's start. Tan inverse 1 pi by 4 plus pi minus cos inverse 1 by 2. Cos inverse 1 by 2 is going to be pi by 3 minus sin inverse 1 by 2. Sin inverse 1 by 2 is going to be pi by 6. Now the rest is we know actually, so it's going to be pi by 4. So if I taking LCM, so this will become 2 pi by 3 minus pi by 6. So pi by 4, let's retain. Let us take the LCM for these two, which is going to be 6. So this will become what? This will be 4 pi. 4 pi minus pi will be 3 pi. Still I can reduce. So this is just going to be pi by 4 plus pi by 2. So on taking LCM, which is 4. So this will be pi plus 2 pi, or it's just going to be 3 pi by 4. The simplest form what we can leave it. Okay. Now notice students, what if I don't remember first year trigonometry? What will happen? Nothing can be done in this chapter. Okay. So without knowing trigonometry table, I cannot write the values of any of these ratios. Without knowing inverse trigonometric properties, cannot be done. So first is we will apply inverse trigonometric properties. But after that, what we are doing? We are doing the table. We are taking the values from the trigonometric ratio table. Correct now. So without knowing the first year trigonometry, most of the things, not most of the things, we cannot study at all this chapter. Okay. So that is the importance of first year trigonometry. If you are not taken up seriously, okay, if you have not studied so far, still you have a lot of time. Okay, I won't say a lot of time. Now this is the best time to start. Okay, read and practice. Let's move to the second problem in this. Now in this one, the second problem is cos inverse 1 by 2. We need to find the value of cos inverse 1 by 2 plus 2 into sin inverse 1 by 2. It's the value, right? Yeah, fine. Now there is no negative sign at all, so simplification will start directly. Cos inverse 1 by 2 is going to be pi by 3 plus 2 into sin inverse 1 by 2 is going to be pi by 6 in terms of radians I'm writing. So we can eliminate this. This is going to be pi by 3 plus pi by 3. Take LCM, so the value is simply going to be 2 pi. Clear, students? Now in this, let's move on to the next. That is problem number 3. The last two are objectives. So problem number 3. If sin inverse x equal to y, then which of the following options holds good? You have to notice all the options are in terms of y, not in terms of x. So they are not asking x values actually. This equation is satisfied which of the following y values. So if sin inverse x equal to y, right, so this can also be written as x equal to sin y. That means the domain of sine. Remember, domain of sine will be from where to where? We used to say this, closed interval minus pi by 2 to pi by 2. This is the one format of telling. Otherwise, y less than or equal to pi by 2, greater than or equal to minus pi by 2, which is present in option B. So in this problem, we need to find out. See, if you are reading here only, see, this will be domain value, this will be range. This is one way. If not, sin inverse x can also be written as x equal to sin y. So now this will become the domain of sine. Anyway, it's going to be the same. It's option B. Now let's go to problem number 4. Problem number 4 is given by, you have to find the value of tan inverse root 3 minus secant inverse minus 2. So let us start simplification because of the negative sign here. So tan inverse root 3 minus secant inverse minus x is pi minus secant inverse x. So tan inverse root 3 pi by 3 minus pi minus, if you want convert it to cos, otherwise secant inverse 2 is nothing but pi by 3. So let us simplify it further. Pi by 3 minus 2 pi by 3. On simplifying, we are going to get minus pi by 3, and minus pi by 3 is present in option B. Right. So this is the first kind or first set of problems in inverse trigonometric functions. Okay. So what is the first type of problems are based on? First type of problems are based on your property number 1 and property number property number 2 and property number 3 in your EPL. Okay, so these two are based on the domain and range. Okay, and this is based on the negative sign. Apart from this, we should know the standard trigonometric table from the first year. Then every problem of the first exercise can be done quite easily. Fine, students. Now let's go to the next. All properties are done, so we have to just see the problems actually. And now, before starting the problems, I just wanted to make a note of the next 3 derivations which I am going to do. It's not there in EPL. Please make a note. Okay, what I am going to do now are required to solve the next set of problems. These properties are not there in the EPL. You stopped at property number 6. I wanted to make a note of property number 7. It's not there in the EPL. I am repeatedly telling you, you have to write down this. So in property number